This is the Community Resilience Inference Measurement application for the Esri Climate Resilience App Challenge 2014, presented by students team from Louisiana State University. Human activities and technology development have greatly changed our environment. For instance, urbanization and industrialization is happening every second around us. Additionally, deforestation and desertification caused by human activities is also in sharp growth. Change of weather patterns, such as global warming, extreme cold, is increasingly catching the public's attention recently. Changes of weather patterns are not only gradually change our world, they also impact our world in other ways that are more fierce, severe, and cause huge damages and hazards. Around 18 categories of major hazards happened in the United States in the past 50 years. For example, avalanches, flooding, drought, landslides, and earthquakes. All these hazards have caused huge damage to human environment, including loss of human lives and property, as well as disturbance to our society. For instance, the state of Louisiana has suffered numerous natural hazards, hurricanes, land loss, and sea level rise. It is estimated that New Orleans will disappear in 50 years if we do nothing about it. Therefore, it is essential to identify the ability of a community to prepare, plan for, absorb, recover from, and more successfully adapt to adverse events, which is defined as resilience by the National Research Council. Therefore, our application is aimed at fulfilling the following three objectives. First, how are the hazards going to impact the world? Second, how do we start preparing for these challenges? Lastly, what makes cities more resilient to climate change? To start preparing for these changes, we should figure out the resilience levels of communities first. The RIM model can not only assess community resilience types, but also select indicating socio-economic variables. The RIM model defines resilience as 3 dimensions and 2 capabilities. The 3 elements are exposure, damage, and recovery, and the 2 abilities are vulnerability and adaptability. Vulnerability refers to the relationship between exposure and damage, whereas adaptability indicates the relationship between damage and recovery. If a community has high exposure to a hazard but sustains low damage, then the community is considered to have low vulnerability. Similarly, if a community sustains high damage but recovers quickly, for example, return of population, then the community is considered to have high adaptability. Resilience is measured according to the 2 capacities. A high vulnerability over adaptability ratio is considered low resilience, whereas a low vulnerability adaptability ratio is considered high resilience. In order to provide the functionalities, we need to embed k-means clustering and DA, and finally show the classification on an ArcGIS map. We have developed k-means and DA from the sketch to suit our model. We wanted our model to be scalable in order to use the modern distributed computing frameworks like Hadoop, which have the APIs in Java. We decided to implement k-means and DA in Java and call those methods from the JavaScript APIs of ArcGIS. In future, with growing amount of data, our design can be easily extended to exploit the advantages of distributed frameworks. Furthermore, Java is beneficial in using existing libraries. For example, we have used the Java Matrix library for computing DA model. In addition, we can easily extend our model for replacing any of the data mining techniques. You need to have Java installed in order to get the application work. Suppose you have already installed Java. Open your browser and type the URL of our app in the address bar at the top left corner in your browser. We have successfully tested it in the Internet Explorer and Google Chrome. Our software only supports Windows system at this point. After the page is loading, you will receive an alert telling the application blocked by security settings. Click OK to dismiss this dialog. Click the Start menu at the bottom right of your screen. Click All Programs. Move your mouse onto the folder Java, and click on it to open the content list. Click on the Configure Java. Change the tab to Security. Click on Edit Site List. Click Add, and type the app URL in it. Click OK to dismiss all of the windows. Click OK. Restart the browser. And now you are ready to use our app. The user interface consists of a control panel on the left and an interactive map on the right. On the control panel, you can select hazard and socioeconomic variables. The map dynamically displays the spatial distribution of the selected variables. On the right top corner, you can switch the display scale between state level and county level and change the base map. You can also click on the map to check the information of each county or state. The pop-up window shows the most frequently happened hazard types and the most damaging hazard types. You can switch to the resilience calculation interface in the left control panel. You can check the checking box to select the states that you want to calculate. We select Colorado, for example. Click Show the Selection button. The counties in the selected states are highlighted in the map. You can also select socio-economic variables for discriminant analysis. Here, we follow the default option to select them all. Then, click the Calculate the Resilience button, and the selected states will be passed to the RIM model program to calculate the resilience index. You need to wait a few seconds before the calculated resilience index displayed in the map. The four colors stand for four different resilience levels. The green represents the usurper counties, which has the highest resilience. The red represents the susceptible county, which has the lowest resilience.